So we have 3 line questions left and I think 3 circle questions left to finish up the chapter. Problem 14 gives me 2 points and it wants me to find the equation of the line that passes through those 2 points. And it tells me I could use the point slope formula or the slope intercept formula to find the equation. Doesn't matter which formula you use. Ultimately, once we get into finding the line, it doesn't matter which equation I use. But regardless of which point or which equation I decide to use to get the equation of the line, I need to do algebra to find the slope. And the algebra that's necessary to find the slope is to form a fraction to subtract the y coordinates of the 2 points in the numerator and the x coordinates of the 2 points in the denominator. And when I do that, I get 10 over negative 2, which is negative 5. So now I need to pick a point. It doesn't matter which point. No matter which point I pick, I'm going to get the same final answer. And along with the point that I picked, I need to use my slope. And then I use either the y equals mx plus b strategy or the y minus y1 equals m times x minus x1 strategy to get the equation of the line. I like using y minus y1 equals m times x minus x1, so I'll do that. Into this equation for y1, I'm going to take the y coordinate of the point that I picked, 3, and plug it in. I'm going to plug negative 5 in for m, and I'm going to plug 7 in for x1. I'm going to clear the parentheses, add 3 to both sides, and be done. When I clear the parentheses, I'll distribute the negative 5 through and get negative 5 times x, and then positive 35 when I do the negative 5 times the negative 7. Now I'm going to add 3 to both sides and get an answer for 14 of y equals negative 5x plus 38. And that's all there is for that. The next 2 problems are even easier by a lot, but they're the kind of problems that if you miss on a test, they're not worth any partial credit because there's no algebra. 15 wants me to find an equation of a vertical line passing through the point 2, negative 6. Vertical lines only have an x in their equation. Since the x coordinate of the point is 2, the equation and answer for 15 must be x equal to 2. 16 wants me to find an equation of a horizontal line passing through the same point, 2, negative 6. Horizontal lines, the equations have a y and they don't have an x, so my answer has to be y equal to some number, and the only number that makes sense is the y that's given, which is negative 6. And that's it for those 2 problems. 3 circle problems left. All the circle problems, I'm going to need to use the equation x minus h squared plus y minus k squared equals r squared. Or if I don't have to use it, I'll have to create it. So problem 17 just wants me to find an equation of the circle that has radius 3, center, x coordinate of the center is 2, y coordinate of the center is negative 1. All I'm going to do is take the x coordinate of the center, put that number in for h. I'm going to change the h to 2. I'm going to take the y coordinate of the center, negative 1, put that number in for k, take the radius, plug it in for r, and not simplify a bit because it makes it easier for me to work with equations of circles if they're not simplified out of the perfectly standard form. Absolutely no algebra for that problem. That's as far as I'd go. It wouldn't be wrong if you wrote this as y plus 1 squared. It wouldn't be wrong if you wrote that as 9. But if you did and I asked you to find the center and graph it, you might mess up because that's the way I used to have students simplify these. And then it was a disaster. So this seems to work better. 18 wants me to find an equation for the circle that has a center of 9, 1, that passes through the point 5, 4. This is kind of a one-step problem that I usually do in 2 steps. The first thing I'm going to do is take the x coordinate of the center and plug it in for h, and the y coordinate of the center and plug it in for k. That's actually going to be in my final answer. My final answer is almost done right here. X minus 9 squared plus y minus 1 squared equals r squared. That's almost my answer. It's not seeable. When I go to write my answer, the only thing I'm going to need to improve upon compared to what I have written right now is I need to change the r to a number that fits the extra information that I haven't used yet. And how do I do that? Well, I take the given point, take its x coordinate, plug it in for x, take its y coordinate, plug it in for y, and this will give me everything that I need to get a value for r in my answer. So I have 5 minus 9 squared, which is negative 4 squared, plus 4 minus 1 squared, which is 3 squared, equals r squared. This gives me 16 plus 9 equals r squared, which gives me 25 equals r squared. I need to square root this to figure out what r is for my answer. I don't need plus or minus because r's, our radius, have to be positive. So I get r is 5, and I put it right into the formula for r. So this circle has a center of 9, 1. It has a radius of 5. One last problem to get through, and it's kind of the monster problem. I don't know why I saved it for last. I got the word problems out of the way. I should have got this out of the way earlier too, but it is what it is. So this equation, if I graphed it, it would actually graph to be a circle, but you couldn't tell anything about the circle. In fact, I couldn't look at that and knew it would graph to be a circle, but it does. And what I need to do in part A is rewrite it so it's in a nice form so I could pick out the center of the radius and graph it. And how did we do that? We started off, we isolated a constant if there was need to do that, but in this case, what I'm going to do is group the x's together, group the y's together, and if the number without the letter was on the left-hand side, I would have moved it to the right-hand side by adding or subtracting. So group the x's, group the y's, and now I'm going to add C1 to the group of x's, and I'm going to add C2 to the group of y's. If you've not done this before, you're wasting your time even trying to learn it from this. I'm not really explaining like I explained when we did the problems in section 2.5. This is for somebody that already knew how to do it and maybe just forgot one thing, and this should jog your memory. But if you completely didn't look at this, you got to go back and look at section 2.5, or section 2.4 actually, because this, you can't just look at it from this video and be anything but confused. So I grouped the x's, I grouped the y's, I added a c after the group of x's, I added a different c after the group of y's, added that same c to the right hand side. And now I'm going to replace each of the c's with numbers by taking the number in front of the first power term for that variable, dividing it by 2, and then squaring it. The first number I'm going to wind up adding is going to be positive 9, because negative 6 divided by negative 6 divided by 2 is negative 3, and negative 3 squared is 9. So for my group of x's, I'm going to write x squared minus 6x plus 9. I'm going to bring down this plus sign, and for my C2, that goes after my group of y's, I'm going to add 25. So after the 10y, I'm going to add 25. And to keep the equation balanced, I'm going to add that 9 and 25 to the right-hand side as well. Now we get into lazy factoring. There's a shortcut way to factor the group of x's. There is a shortcut way to factor my group of y's. And I'm just going to add those numbers up. So always the factoring can be written as one factor with an exponent of 2. My first parenthesis is going to lead with an x, and what goes in the parentheses is the number in the parentheses before I finish up the C1, before I squared. So my first parenthesis is going to have a minus 3 in it. My second parenthesis always leads with a y, and the number in the parentheses right before I found out what C2 is, along with its sign, will go in the second parentheses. That's going to be a positive 5. And on the right-hand side, 2 plus 9 is 11, plus 25 is 36. This is nice, but when I look at this, maybe I don't know what the center or the radius of the circle is. The x minus 3 squared, not an issue at all, but the y plus 5 squared is a semi-issue, and I'm going to do the reverse. Usually we make double negatives into a plus. When I'm working with circles, I'm going to make a plus into a double negative. Pluses in my parentheses are not my friend. And then on the right-hand side here, I'm going to square root the 36 and get 6. I'm going to write it as 6 squared. This is going to be my answer to 19a. This is the equation of the circle. It's written in standard form, and the standard form is really nice because I could just glance at it and know my answer to part B, the center of the circle. The center of the circle, I pull the numbers after the minus signs in each parentheses. The x-coordinate of the center is the number after the minus sign, which is positive 3 from the first parentheses. The y-coordinate of the center is the number after the minus sign in the second parentheses, which is negative 5. So done with part B, identify the center. And now for part C, the radius is the number that's being squared to the right-hand side. So my radius is going to be 6. Lastly, I need to sketch a graph. And in this section of 2.4, for part D, to actually do my graph, what I would have done is I'd plot the point 3, negative 5, and then I'd go up 6, down 6, left 6, and right 6, and draw my circle. I wanted a more accurate graph, so I had Desmos graph this for me. So here's my 19D. I start off plotting the point 3, negative 5, and then I go right 2, 4, 6. I can go left 2, 4, 6. I can go up 2, 4, 6, because each of these lines are 2 apart. I can go down 2, 4, 6. And then I would try to connect these with something that wouldn't even remotely resemble a circle. But you'd plot the center, left 6, right 6, up 6, down 6, and then connect those points, those 4 points, with a circle. Use a compass if you have a compass and you like using those, would be really nice. But the quality of my graphs in the videos for section 2.4, you don't need to be any better than that. And if you're worse than that, not such a big deal anyways, as long as I can tell what you basically were trying to do the right thing, plotting the center in the right place, knowing how to get the 4 points on the boundary of the circle so I could draw up a good graph. So that's everything for our first test. I never ever have anything on the test that isn't just like something on the practice test. If you do all the problems on the practice test, you should be perfectly prepared for our test.